So in this video, we are going to see problems from exercise 13.2, which belongs to chapter number 13, surface areas and volumes. So let's start with problem number 1. So let's read what the problem says. The curved surface area of right circular cylinder of height 14 centimeter is 88 centimeter square. Okay, so this is the key information. Height is 14 centimeter and the curved surface area is 88 centimeter square. Now let's quickly visualize this right circular cylinder that the question is talking about. So this is two straight lines and then one more circle at the base. Okay, so let me try to draw it a bit better. Okay, so this is not very up to the scale, but fine, for us to just have a simple and quick visualization of what the problem actually demands from us. So let's read the statement once again. The curved surface area of a right circular cylinder, so this is a right circular cylinder of height 14 centimeter. So let's mark the height. So as we know, the height is basically this entire height of the cylinder. Okay, so I'm just going to write here height h is equal to 14 centimeter. Okay, and the curved surface area is 88 centimeter square. Okay, so we all know what is the formula for curved surface area. I'm going to quickly write it down. Curved surface area of right circular cylinder. I'm just going to write a short form, RCC. Right circular cylinder is equal to 2 pi r h. Okay, so h is this, the height of the cylinder, and what is r? R is this radius. So r is the radius of this circle. So this thing is r. Okay, radius. So this r and the r for the top circle is basically both are same. Okay, this r, in fact this circle and this circle are basically the same circles. They are congruent or similar to each other, although it doesn't look like in this figure. But this circle and this circle, the base of the cylinder and the top of the cylinder, both are exact same circles of same radius and of course same area. Okay, so if you know this r of the cylinder radius and if you know the height of the cylinder, then the curved surface area of the right circular cylinder is given by this formula 2 pi r h. So 2 pi r is actually the circumference or the perimeter of this base, and if you multiply it by h, you get the total curved surface area. Okay, so the curved surface area of RCC is 88 centimeter square. So I'm just going to substitute all the values. So let's draw a line here. Okay, so in this formula, let's substitute the values that we know. So therefore 88, which is the curved surface area, is equal to 2 pi, r is unknown and h is 14 centimeter. So I'm going to substitute this. So if we solve this equation, okay, r is the one unknown variable, we'll get the value of r. Now let us read what the question asks. The question says find the diameter of the base of the cylinder. So we have to find the diameter of this base of the cylinder. We all know diameter of any circle is equal to twice its radius. So all we need to do is find the value of r. Once we find the value of r, all we have to do is multiply it by 2, because 2r is equal to the diameter, which is what the question is asking us. So let's continue solving this question. Solving this equation. So okay, so yeah, so therefore 88 is equal to 2 into pi. I'm going to write it as 22 by 7. This is the value of pi, into r into 40. Okay, so as we can say, this is 7 2s are 14, then this is okay, and 2 into 2 is 4, and 4 into 22, 4 into 22 into r. Okay, that is equal to 4 2s are 8, 4 2s are 8. 88 into r is equal to 88 here, and therefore we are getting r as equal to 88 divided by 8, which is 1 centimeter. Unit is very important, don't miss the unit. The unit here is centimeter. R is equal to 1 centimeter. So now we have got the value of r, which is equal to 1 centimeter. I am just going to note it down. R is equal to 1 centimeter. And now they are asking us to find the diameter of the base of the cylinder. So I'm just going to write it here. Okay, so that is equal to 2 times r, which is equal to 2 times 1 centimeter, and that is equal to 2 centimeter. So 2 centimeter is the diameter of the base of the cylinder, which is what the question is asking. So very simple and straightforward question. All we have to do is use this standard formula for the curved surface area and just substitute the values and find the value of R. Now let's quickly erase this everything and go to question number 2. So yeah, okay, so let us just bring this down. Yes, this is our question number 2. Now let's read the question. So let's bring it in the focus. Okay, so the question reads, it is required to make a closed cylindrical tank of height 1 meter and base diameter 140 centimeter from a metal sheet. Okay, so as soon as you are starting to read the question, don't just read the entire question and get confused and overwhelmed by the piece of information that is given. What you should do is, as you are reading the question, you try to visualize the question and start putting out the values that is given to us. So for example, here we know that this question talks about, okay, there is a highlighter. This question talks about a closed cylindrical tank. So first of all, let's quickly draw a simple closed cylindrical tank. So something like this. This is our circle, and this is the height, and this is our another circle. Okay, so this will be our closed cylinder tank of height 1 meter. So immediately let's make a note of height. So this is our height. Okay, so I'm just going to write here h is equal to 1 meter. Okay, and let's continue. Height 1 meter and base diameter 140 centimeter. So the base diameter is 140 centimeter. So once again, let's draw this. This is the whole diameter. Okay, this is given to be 140 centimeter. So 140 centimeter, I am just going to convert it to the same unit. Since this is meter, so let's write it as 1.40 meter. Okay, 100 centimeter is equal to 1 meter, so just divide it by 100. So the base diameter, I am just going to write a d. In fact, d is equal to 1.40 meter. Now, so as we are reading the question, we are visualizing whatever information is given to us. This is very important to solve the questions in a very easy and confident way. Otherwise, if you are not visualizing what is given to us, then everything is in front of your eyes in air, and you can easily miss out very key pieces of information and make very simple mistakes. So to avoid these simple mistakes, this visualization as you are reading the sentence, not after reading the whole sentence and the whole question, as you are reading the sentence in the flow, you have to visualize whatever is given to you. Okay, so the first statement is done. Now, how many square meters of the sheet are required for the same? So we want to construct this closed cylindrical tank. Now the word closed is very important. I'm going to highlight it separately. Okay, this word closed is very important. The word, okay, closed cylinder means that this roof and this base of the cylinder are also included. We have to close it. Okay, there could be a question where they will ask you open cylindrical tank. In that case, this will be open. Okay, the top will be open and only the base will be there, and thus the total curved surface area of the cylinder will be different. So depending on the question and what exact three-dimensional figure they are trying to portray, we have to change our formula for calculating the curved surface area or the total curved surface area. So in this case, it's very straightforward. Since it's a closed cylinder, we will use the standard total surface area formula for the right circular cylinder, which is equal to what? It is equal to, I'm just going to write it down. So now we have all the dimensions. Let's bring this here. Okay, let me create this line here. Okay, so we need to know, or we need to calculate the total curved surface area of RCC. RCC is right circular cylinder. Okay, that's equal to what? So it is equal to the curved surface area. So I'm just going to write here 2 pi r h, which is the curved surface area, plus this pi r square. Okay, the area of the top, pi r square, top lid you can say, and the base pi r square. So pi r square plus pi r square is equal to 2 pi r square. So this is the formula for the total curved surface area of RCC, right circular cylinder, and that is exactly what the question is asking us, because it's a closed cylindrical tank. If it was open cylindrical tank, then we will take only this pi r square, the base, and we will not take the top pi r square. So this will be just pi r square, not 2 pi r square. So depending on the question, the formula will change. So be alert, be a little bit cautious about that. Now we know this is the formula to be used. We have the value of h. Okay, h is 1 meter and diameter is 1.40 meter, but we need radius. Okay, so we are just going to say that is, I'm just going to write here, that is r radius is equal to half the diameter. So 1.4 divided by 2, that is equal to 0.7 meters. It's important that everything is in the same unit. Okay, the height is in meters and this radius is also now in meters. So let's start substituting the values. Let's come here a bit. Okay. Before we start substituting the values, let us take out the common portions, which is 2 pi r, and this will be h plus r. Okay, so 2 pi r is common, this 2 pi r, and here 2 pi r is common, and this. Now okay, now we are free to directly substitute the values. So this will be equal to 2 pi okay, hold on. For pi we are going to substitute 22 by 7. So 22 by 7 into r. So this is our r. Okay, 0.7 meter. So I'm just going to write here, okay, 0.7 meters. Okay, and h is 1 meter, so 1 plus again 0.7 meters. Okay, so this 7 and this 0.7, they will cancel each other, so that will be equal to 2 into 22 into, this is 0.1. okay, and this will be into 1.7. now it's just a simple multiplication. This is equal to 44 into, this will be 0.17. okay, so that's equal to, this is basically 44 into 17 whole divided by 100. okay, so let's do this multiplication. So 17 fours are 68, so 8 6 1 carry, and once again 17 fours are 68 plus 6, that's going to be equal to 74. So that's equal to 74, and the whole divided by 100, that's going to be 7.48. and what is the unit? The unit is meter. So everything was in meter, so this was in meter, and even the height was in meter. So what we're going to get is meter square. So I'm just going to write here meter square, and in fact I'm going to box it, 7.48 meters square. So what was asked to us? Let's go back to the question. The question had asked how many square meters of sheet are required for the same to construct a closed cylindrical tank of height 1 meter and base diameter 140 centimeter. Okay, the number the area or the total amount of metal sheet that will be needed is 7.48 meters square. So that is our simple answer. I'm just going to write it down. So that is equal to 7.48 meter square. This much amount of metal sheet will be required to make this closed cylindrical tank. That's all.